So this video is going to be done so that you can have a chance to do a 3D resultant problem, and also to give you an idea of the expectations of what I want turned in for a problem, and also going over some of the grading of such. So in this problem, you are asked to determine the magnitude and coordinate direction angles of the resultant force acting on the bracket. So in here you see a picture given. It's got a bracket and it's got two forces, F1 and F2, acting on this bracket, and you are to determine the resultant force. So what I want you to do now is go ahead and pause the video, and I want you to sketch out the given. In this case, the given can be simply a nice three-body diagram, and then also state defined. So once you've complete that, unpause the video. Okay, here is the given. I just simply say given, and I draw my X, Y, and Z axis. As you note here, I'm sketching the Z and Y at 90 degrees to each other, and then I kind of draw the X at a 45. I then sketch in as best I can, kind of mimicking the picture that I had to draw in my forces. I then sketch in the necessary magnitudes of these forces and also the direction there. Now, as a tip, I also used a dotted line to indicate and helped determine, how these forces and these degrees are measured from. I also state clearly, and it's just pretty much just rehashing what was in the problem statement: find magnitude and direction angles of the resultant forces. All right, so now what I want you to do is solve each force independently. So we'll do force 1. So go ahead and pause the video, and then just work on force 1. Force 1, by looking at the information given to us in the picture and also in my free body diagram, is spherical coordinates. So the information that defines what a force is in spherical coordinates would be F1, which is the magnitude, in this case 450 newtons, and then the pi, which is the angle off of the z-axis. Okay, and that is, now you measure, if you look back again at my free body diagram, you notice it's 45. Okay, but remember, it is measured off the positive z-axis, and it just happens that 90 minus 45 is 45. And the delta, which is measured off of the x-axis, what they show us is the angle of 30 degrees off the y-axis. So to get my delta, I have to add 90 to it. So that gives me a delta of 120. I then state the equation for the various forces, Fx, Fy, and Fz, and then solve for it. So then you can see my answers, minus 159.1 I newtons. For Fx, Fy is 275.6 J newtons, and Fz is 318.2 kilonewtons. And you notice that I am carrying forward 4 significant digits, as we want to carry over at least the 4 significant digits, and when we report our final answer, we will report just 3 significant digits. Okay. The next thing I want you to do is solve the component forces for F2 now. So go ahead and pause the video, and let's work on F2. All right, force F2, by looking at the information given, is defined by directional cosine. So we have F2 with a magnitude of 600 newtons, a delta X of 45, and a delta Y of 60. So we are lacking our delta Z. So we have to derive that. And again, I'm going to state the equation, which is cosine squared delta X, theta X, plus cosine squared theta Y plus cosine squared theta Z is equal to 1. So then I use that equation, I plug in the necessary information, and I solve for theta Z, which we get equal to 60 degrees, but as we note when we're looking at the drawing by inspection, we can tell that it's going to be greater than the 90 because it is obviously, when it's drawn, is in the, it has a z component, as you can see, and that's why it's helpful to draw those dashed lines on there. And so 180 minus 60 is 120. So by inspection, our delta z is 120. We then state the governing equations for the various component forces for Fx, Fy, and Fz, and we solve for our components, and we get 424.3 I newtons, 300.0 J newtons, and minus 300.0 K newtons. And again, these are all expressed to 4 significant digits. Next, I'm going to solve for the force resultant and for magnitude and the directional cosine for that. So go ahead and pause the video and solve for both the magnitude and then the directional cosines for this resultant force. The resultant force is going to be the addition of those vectors together, F1 and F2. So I'm going to go ahead and state the general equation, then I'm going to state F1, and I'm going to list it out in Cartesian coordinates. And F2 in Cartesian coordinates, I like doing it this way because then underneath it I just do FR, and I just sum up my I's, J's, and K's and post that. And so my vector coordinates, or my vector description for the force resultant is 265.2 I plus 575.6 J plus 18.2 K, and it's newtons. And again, I'm reporting 4 significant digits. I then state the equation for determining the magnitude of that, which is Pythagorean's theorem. I'm going to solve for that, and I get 634 newtons. I'm not stating the equations because I've already stated those in the previous, which was Fx equals F cosine of theta x. So I'm just going to use that equation, and I'm going to solve directly for theta x, theta y, and theta z. And again, I'm reporting it to 3 significant digits, and I get 65.3 degrees, 24.8 degrees, and 88.4 degrees. Now, let's look at what points would be awarded for what areas. So if this problem was worth 20 points, okay, 2 points would be the maximum awarded for what would I call the given and the free body diagram. In this case, the given is satisfied by just a nice free body diagram, as you see here, and that would be worth full credit 2 points because it clearly defines everything, has all the angles on there, forces, magnitudes, everything, and has nice dashed lines to represent all that. And the find is worth 2 points too, and that is just stating the actual problem itself. In this case, pretty straightforward, just a brief written description of what you're looking for. You can even put in there, put in the symbol, say, you're looking for F sub R plus theta x, theta y, theta z. The next thing we're looking at when grading would be equations stated. So if you note, if you look at, these are the governing equations that I want to see in your answers. So when we look at, say, for F1, it clearly we can see I stated the necessary equations. And also in F1, when we're solving it, you'll notice also I'm repeating what are the known values there as well, which is nice. But all the governing equations that we're using there are clearly stated, and then the numbers put in. Also, you can see that when we did it for force F2 and also for the resultant, we always state the equation and then we put the values in and then solve and report it. So that's worth 4 points in a 20-point problem. Now, calculations answers. Okay, this is all the calculations you see, and that would be worth a total of 8 points. Okay, so if you missed a calculation, you get some off. So if there were, in some cases, it might even be only half a point because there are a lot of calculations in this. And of course, wrong answer would also be a deduct, but probably no more than a couple points. Units and significant digits. Okay, so use of units, especially when reporting the answer, make sure that you've got 3 significant digits and you have the proper units stated. Okay, and that would be worth 2 points. And neatness and boxing the answer. Okay, general neatness. What I've shown is considered. I would consider it neat. I mean, you can definitely be neater than what I've got, and it can be even a little less, not as neat. But you notice I try to keep everything on one line. I have space. Things are indented, and I have boxed my answer. Okay, and just boxing your answer will get you a point. If you don't have it boxed, that's a -1. So that's generally how that would be graded.